Hello guys, this is Jay and I am going to solve problem 21.65. So let's dive into it. The question is, two loudspeakers in a plane 5 meters apart. So two speakers 5 meters apart. And are playing the same frequency. If you stand 10 meters in front of the plane of the speaker, center between them. So you're standing exactly center. You hear a sound of maximum intensity. This is 10 meter, and here's maximum intensity. So next line. As you walk parallel to the plane of the speakers, staying 10 meters in front of them, you first hear a minimum of sound intensity when you are directly in front of one of the speakers. So if you gradually move towards this or this side, either one, so I'll go this side, right in front of the one of the speaker, there'll be minimum intensity. So in this case, we gotta figure out the definition of constructive and interference and destructive interference. So I don't know if you can see, but yeah. So constructive interference, it occurs at a point where the both path length differences is an integral number of wavelengths. So the equation is delta R equals to integral times the wavelengths. M can be integral can be 0 to 1, 2, 3. Yeah. Also, the lambda is wavelengths and M is integral. Yeah. Destructive interference. It occurs at points where the path length difference is a half integral number of wavelengths. So it's delta R equals M plus 1 over 2 times the wavelengths. So let's see. Okay, we gotta find the delta R. So it's this, it's the same as 10 meter, but we gotta find the distance here to here. So it'll be R2, and this is R1. So it'll be R2 negative R1. The equation will be 10 times using Pythagorean equation. This is R2 and this is R1, 10 meter. So using calculator, I already did it. It'll be 1.18 meter. Then we know it's a minimum intensity. So it will be destructive interference. Destructive interference equation, once again, will be over 1 over 2 times the wavelength. But in order to get a minimum intensity, the M will be 0. So it's just simply 1 over 2 times lambda, wavelengths. We already know the delta. It's 1.18 meter. is 1 over 2. So if I switch it, lambda will be 2.36 meter. So our question is, what is the frequency of the sound? Frequency is, the equation for frequency is velocity over lambda. We already know the lambda, so we change the equation. It'll be, it goes up, it goes down, velocity over frequency. Also, we gotta know the speed of the sound. Speed of the sound is 340 meter per second. So we just plug it in, 340 meter per second over no, my God, what am I doing? We are going to get a frequency. We don't have to change anything. So frequency equals to, I'm sorry, velocity of the sound is meter per second over 2.36 meter. So it'll be, I already did it, that'll be 144 hertz. Yep. And the assessment, let's see. I think it's reasonable because it's not a crazy number. So I think, yeah, assessment will be, let's see. Yep, it's not crazy number. It's not that big. It's not that small. It seems reasonable. So, yeah. Thank you for watching.